So we're moving on to problem number 8, and I want you to notice a few things. One is I've labeled a couple of points in this problem, point A, B, and C. I've also labeled lines A and B, which are parallel to each other. Notice they each have one arrow, and they're sort of diagonal. And then I've labeled angles C and D, which are more or less horizontal, and they have a different direction. So they have a double arrowhead. So we've got two sets of parallel lines. Each set is pointing in a different direction. Each has a different direction. I've also labeled points A, B, and C, which we may refer to a little bit later. Also notice that the measure of angle 3 question sort of flipped onto the next page, but it's part of this question. So we're going to also have to come up with the measure of angle 3. Those are the 3 labeled angles. So let's take a look at this and let's figure out how are we going to do this. We need to find a relationship between the angles that we're given, which is this angle here, which is 41 degrees, and this angle here, which is a right angle, and somehow related to angles 1, 2, and 3. So let's focus first on angle 1. And let's notice that both angles 41 and angle 1 share a common transversal, which is line D. Okay, line D makes up one of the sides of angle 41 and one of the sides of angle 1. And that happens when D crosses parallel lines A and B. So when these two lines are crossed by D, we get these two angles. These angles are between A and B, so they're interior angles, and one is above the transversal D and one is below the transversal D, so they are alternate interior angles, and that makes them congruent. So angle 1, the measure of angle 1 is equal to 41 degrees. Okay. Now, what is another relationship that we can see? So now we know angle 1 is 41 degrees, and if we look at angle 3 and angle 1, what we'll notice is that there is a relationship between these two angles. Angle 3 and angle 1 share the same transversal, which is line B. As B cuts across C and D, it creates both angles 1 and 3. And you'll notice they're on opposite sides of the transversal B, and they're between the parallel lines C and D, which makes them also alternate interior angles, and therefore they are also congruent. So angle 3 down here is equal to 41 degrees as well. We can put that here, 41 degrees. Well, angle 2 is a little bit elusive. It's a little bit hard to find an angle that has a relationship, a simple transversal relationship to angle 2. But one thing that we can see is that there is a relationship between line AB, if we extend it up and down a little bit, and line D, okay, because AB is actually a transversal that cuts both parallel lines C and D. Okay, if you see that, let's draw these out a little bit. Line D and line C are parallel to each other. AB intersects them both. Okay, and there's a right angle over here, which means that the corresponding angle down here is also a right angle. So since these share the same transversal, and since they're both being intersected by the same parallel lines, corresponding angles are congruent. Now, this angle is a right angle down here, which should be enough to tell us that this angle up here, ABC, is also a right angle. Okay, because this is a line, and we have a linear pair, angle ABC, and if we put this point as point D, we'd have angle DBC down here, and angle DBC are a linear pair. And therefore, that means that the measure of angle ABC plus the measure of angle DBC is equal to 180 degrees. But we know that the measure of angle DBC by corresponding angles is 90 degrees. And then we can easily solve for the measure of angle ABC to give us the fact that the measure of angle ABC is equal to also 90 degrees. So ABC is equal to 90 degrees, but what about angle 2? Well, we know by the angle addition postulate. Okay, so we have our angle addition postulate, which tells us that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle ABC. So the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle ABC. Well, now we can use substitution. The measure of angle ABC we know is 90 degrees. The measure of angle 3 we know is 41 degrees, and the only thing we have to solve for is the measure of angle 2. Well, by subtracting 41 from both sides, we find out that the measure of angle 2 has to be 49 degrees. And now we've solved our 3 problems. 3 questions were what is the measure of angle 1, measure of angle 2, and measure of angle 3, and they are 41 degrees, 49 degrees, and 41 degrees.